We will be discussing today 2-1 quadratic functions, how to transform quadratic functions, the notes, and I'm gonna help you on some questions on the homework. So let's start with 2-1 quadratic functions. Fill in the table and graph f of x equals x squared. Remember, this is a quadratic function, so the graph will be a parabola, a U shape. In order to be able to graph something like this, you can use your calculator, but for my pre-AP class, you are not allowed to use a calculator. You have to show me all your work. So basically think of numbers like -2, -1, 0, 1, and 2. And let's plug in those x values into f of x to find the y value. So by plugging in -2 over here, -2 squared, remember, -2 squared, you have to put it in parentheses. So -2 squared would be a 4, -1 squared would be a 1, 0, 1, and 4. So the ordered pairs are -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So let's plot those points and see how our quadratic function or graph would look like. So -2, 4 would be somewhere over here. -1, 1 over here, 0, 0, 1, 1, 2, 4. Connect those points, and this will be your y equals x squared, which is the parent function. Now, let's look at the domain. Remember, domain is the x value. So, from the left side to the right side, what part of the x-axis is covered? Remember, this is going to extend forever. So, my domain is going to be -infinity to infinity. And as for the range, it means from the bottom point, which is over here, is a 0, all the way up. So it's 0, plus infinity. And remember, the 0 is included since we do not have an open circle over here. Now, f of -3, it means you have to plug in -3 in the equation. So -3 squared would be a 9. So f of -3 is a 9. Now, f of x equals to 4, it means that x squared is equal to 4. Remember, to solve this, you have to square root both sides. So x is equal to plus or minus 2. Since you have to think, what is a number that whenever you square, you get a 4? Basically, if you square 2, you get a 4. So if you square 2, you get a 4. Let me do it again. So basically, if you square a 2, you get a 4, and if you square -2, also you get a 4. So the answer is not only 2, it's, as you can see, 2 and -2. So x would be plus or minus 2. Now, so far we've been talking about the parent quadratic function. Now we're going to see how every time we change the parent function by introducing a negative or adding something to the 2 or subtracting something from the x. So as you can see, now we're interested in seeing how we transform the quadratic function, the parent quadratic function. Now, by looking at f of x equals to -x squared. Now, what I'm going to do is I'm going to graph it on the calculator to show you what will happen every time you introduce a negative. But remember, my pre-AP class, you're allowed to check now, but on the test, you're not allowed to use a calculator. So let's use a calculator on y equals. So y equals, we're going to put the parent function over here. So it's going to be x squared. I'm going to make it bold so I can compare my new function to my old parent function. So I'm going to press enter. And as you can see, the graph will be bold. Now on y2, I'm going to write down the new function, which is -x squared. So let's write that down, -x squared. Now let's graph them. As you can see, I have 2 negatives for some reason. Now let's graph. This is my parent function, and this is my new function. As you can see, the new function is reflected across the x-axis. So the y is becoming negative. As you can see, the y was always positive on the parent function. Now on the new function, negative x squared, all the y is negative. So you're allowed to use a calculator to check your work, but you have to show me the work in order to get a full credit. So how to show the work? Remember, every time I ask you to describe the transformation, and this is the question, describe the transformation of each quadratic function. So you have to show me, or you have to start with the table of the parent function. Now if you look at number 1, for -2 we had a 4, for -1 we had a 1, for 0 we had 0, 1, 1, and 2, 4. So this is the table of the parent function. Now you have to introduce a new column. As you can see, negative x squared, it means then y is becoming negative. So over here we have to introduce a new column and put negative y over here. So 4 will become -4, -1, 0, -1, and -4. So my new coordinates are this x over here, there's no change done to the x, and this y over here is my new y. So my new coordinates are -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. Now by plugging them in, you should be able to see the exact same graph over here. So let's check our work. -2, -4, so it's going to be somewhere over here. -1, 1, 0, 0, 1, -1, and 2, -4. As you can see, always the y-axis, or this line passing through the vertex, which is either the top point or the lowest point, basically. So as you can see, it's symmetrical. This is something good to look at. So this is my new function. Sorry for that. This is my new function. Let me erase it to make it better. So my new function is going to be this one over here. So as you can see, it is reflected across the x-axis. Now by looking at the domain and the range, remember domain means the part of x which is covered by the graph. So as you can see, it is -infinity to +infinity. The y, it means from the bottom to the top. So as you can see, it's from -infinity, since this continues on forever, all the way up to 0. So my range is going to be -infinity to 0. As you can see, 0 is included, but -infinity can never be included, so that's why we have parentheses. Now by looking at this graph and looking at the graph on the calculator, they do match, so my work was correct. I want you to remember, every time you don't see parentheses on the new function, it means the change is going to be done to the y. So by looking at h of x, you can see that there is parentheses, so the change is done to the x. Here, no parentheses, so the change is done to the y. So you create a column next to the y. So let's go ahead and do number 3 together. I'm going to start with a calculator to show you. I'm going to keep y1 equals x squared, and I'm going to change this to parentheses x plus 2 square. Now I want you to pay attention to the graph. So let's graph it. The bold is the parent function, and the other graph is my new function. As you can see, x plus 2. Most of you might have expected for the graph to move to the right 2 steps, but the graph shows us over here, by graphing it, we can see that it moved to the left 2 steps. So other than that, I want you always to remember, every time there is parentheses, let me write it down. Every time you see parentheses, we know by now that the change is done to the x. So change the x. And the other thing I want you to remember is that it's always going to be opposite to what you expect. For example, it's x plus 2, you expect it to go to the right, but in reality it went to the left. Let me lower this down so you can see what I wrote. So x plus 2, you expected it to go to the right, but in reality, as you can see, it moved to the left. So it's opposite to what you expect. every time there is parentheses, the change is done to the x, and it's opposite. It's not x plus 2. In reality, it's x minus 2. So let's write down the... Remember, we always start with the parent function. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Again, there's parentheses, so I put a new line next to the x. The change is going to be done to the x. Y is going to stay the same. So this is my y is going to stay the same. Now the change is done to the x and it's opposite. So instead of x plus 2, I write x minus 2 over here. This only happens when there is parentheses. It's opposite and it's done to the x. So negative 2 is a 4, negative 4, negative 3. Remember, what we're doing is we're starting with this point and subtracting 2. So negative 1 minus 2 is negative 3. 0 minus 2 is going to be negative 2. And then 1 minus 2 is going to be negative 1. And 2 minus 2 is 0. So this is going to be my new x. My new points are negative 4, 4. Negative 3, 1. Negative 2, 0. Negative 1, 0. And 0, 4. These are my new coordinates. Let's plot them and see what graph we're gonna get. It should be the same graph we saw on the calculator. So negative 4, 4. It's gonna be here. Negative 3, 1 is gonna be here. Negative 2, 0. Negative 1, 0. And 0, 4. So this is gonna be my new function. As you can see, it's exactly like the calculator. It did move to the left. It did move to the left, as you can see. So parentheses means change done to the x, so create a column next to the x, and it's opposite. Now if you look on the previous one, there's no parentheses, so the column is next to the y. There's a change to the y, and it's exactly as it is, negative, so negative. Now let's go ahead and think of the domain and range. So the domain of this is going to be from negative infinity to infinity. Negative infinity to infinity. And the range is from the bottom, which is a 0. As you can see, the range starts from the 0 all the way up, so from 0 to plus infinity. That's my range. Now let's summarize. Every time you see a negative over here, it means that the graph is going to be reflected across the x-axis, as you can see. Now compare this function to this function. As you can see, it's flipped. So there's a reflection across the x-axis. Compare this to this. It's shifted 2 steps to the left. So let's write it down. Every time it's a negative x squared, so I expect to see a reflection, or it's going to be reflected across the x-axis. It's going to be reflected across the x-axis. This means every time you see x plus 2 squared over here, as you can see, it's x plus 2 squared. So it means that it's going to go 2 steps to the left. So let's write it down. Here it's going to be shifted 2 steps to the left. That's the transformation. Now let's look at number 3. G of x equals to x minus 2 squared. By looking at this, I can see parentheses, so the change is going to be done to the x, and it's going to be opposite. So instead of x minus 2, I put x plus 2. Remember that. And I expect it to go to the left because it's x minus 2, but in reality, it's going to go to the right. So the transformation is going to be 2 steps. It's going to be shifting, or it's going to shift. The new graph is going to shift 2 steps to the right. Now you can graph it on the calculator and you're gonna see that's gonna shift to the right, but let's do the table. It's -2, 4,